welcome to Purple Teaming Outbound HTTPS. I'm going to give a chance to describe what this talk is about, so if you realize this isn't for you, it's okay. You can change. All the materials are online, like I said. Oh my God, something happened to the formatting of that. Anyway, yes, there's a GitHub repo where you can reproduce all the proof of concepts I'm going to show today. Because I only have screenshots of like success, but if you're skeptical, you want to find out for yourself, you can go do that. So who's this talk for? It's for, hey, Purple Teams. Really, it's for anyone who's interested in what can the bad guys do the good guys can protect, and how can you all learn from each other and add detections. So yeah, what are we going to cover? So there's kind of the intro material of like what, why, how. I'm going to then intro what the attack paths are going to be. And that's actually most of the material. Like 90% of the material is the attack side. And I've actually got quite a lot of time for my talk, so I'm going to take a Q&A break at that point, a couple of minutes, give it a chance, see if there's any questions that fell out of the attack paths. And then I'll go on to preventions and detections, which are fair in terms of content, not so much. I'll summarize, and then we'll have time for Q&A if there's time. So what? Like, this is like a really simplified like tech stack, architectural diagram you might have at work. You're some SaaS, you're customers who use browsers to talk to this internal service that uses the database, and your internal service talks to this third-party external service. Now, if you're looking at this, okay, who here does like security reviews at work? Yeah, quite a few. Anyone do answer any third-party like vendor vetting where they say, hey, is all your data encrypted in transit? Okay. Yeah, do you ever, like me, just go, we're good, it's HTTPS, job done, I don't even think about this anymore. Turns out this is actually a huge blind spot, because you've got an adversary that compromises the host. Things like the incoming data coming through HTTPS, kind of open season, because normally it's the handshake is terminated before you get to a particular process. So you can TCP dump that. The creds for accessing the database normally lying around as well. But this part here, that's a bit of a blind spot. And without thinking too hard about it, I would just say, oh yeah, you're totally safe. So this talk, if anything, is a list of ways in which you are not safe. So why, if you're a Purple team, are you going to choose this as an exercise? Well, really, it's for one of these three reasons. So it might be that there's really sensitive data that's in transit that's maybe not easily accessible through other means. You might be an adversary, you've compromised something, you don't know what you have yet, and really you want to go recon, like, oh, what is this interacting with and how? What's the protocol here? And intercepting your outbound HTTPS can be really stealthy. You're not going to trip any alarms because you've got these new connections to databases that are like executing these unusual queries or anything like that. So a bit of a how. There's this concept of assumed breach when you're emulating adversaries and doing Purple teams. And really, it's the scope. So the scope of this talk is we're not going to worry about anything that happened up until the point where the host that's running this internal service got compromised. And similarly, we're going to assume exfiltration. We're not going to worry about, well, once I intercept this data, how do I get it out again? So remember that once we start talking about preventions and detections, because a lot of you are going to be like, ooh, what about egress? What about egress? And it's like, well, yep, calm down. That's out of scope. And really, you want to do these things, because you could just say, well, let's just prevent exfiltration from ever happening. Let's prevent breaches from ever happening. How does that pan out, right? Now, you want to plan for failure of those things. Yeah, and then lastly, I'm going to present you with a menu of options, and you want to choose one of those. So there's 4. Oh, by the way, Midjourney is amazing. Just put like aggressive red My Little Pony conducting cyber attacks. That's what I got. Mwah. I love that maybe too much. Yeah, so I'm going to go through 4. They've really, when I look at them and try to contrast them, they've got varying degrees of coding skill. And then, possibly more importantly, they've got various varying degrees of preconditions that they need. I think a lot of that would inform which ones are your adversaries capable of, and then what are the actual limitations you have in the host that you've compromised? Like maybe you don't have, what Linux capabilities do you have? Do you have root access, that kind of thing? And I think in a good framing, and someone in the audience knows that they told me this, these are all really variations of person in the middle. Now, we think of person in the middle as someone out there in the internet is like intercepting my packets and doing something bad. Well, just imagine that in the context of inside the computer on the actual host that has been compromised. And that's basically what we're doing. All right. Oh, I didn't mention, by the way, if you want to interrupt and just ask a question, just raise your hand or start talking. I'm good with that. So, yeah, feel free. So there's going to be 4. This is, between the internal service on the compromised host and the external service, your crown jewels is inside that HTTPS data. So there's 4 I'm going to walk you through. The first one is your interpreted code, which is really, it's everything that your software engineers have used to make this internal service work. So it's both, maybe it's your server.js file, right, which is code that your engineers wrote, and then a whole bunch of other libraries, like 95% of the code is probably other people's code from open source. And then if you're interpreting code, you're bringing a binary with you to do that, like maybe Node or Python. And shared library starts to get a little bit surprising. Like your operating system comes with a whole bunch of shared common functionality, and OpenSSL is a really common one. And that's the one that we'll focus on here, which is, every single executable you have is not shipping with an entire implementation of how to do HTTPS. That comes with your operating system, kind of like a Windows DLL. And that's an opportunity to do nasty things. And a transparent proxy, it's kind of like that classic man in the middle HTTPS proxy. And you can see like legit examples of this, although this isn't on host, would be like a Palo Alto firewall that just ships with like break and inspect functionality, because that's an awesome idea. So I'll show you a really cool tool that actually, if there's only one thing you take away from the talk, the tool that I use for this transparent proxy it is so good. I use it all the time for everything. But having a HTTPS proxy transparently on the host, that's a real surprise. I don't think anyone on incident response is looking, or detection and response is looking for that one. All right, so onto the first one. So this is attacking the interpreted code itself. There's quite a lot of coding. Maybe you're not changing many lines of code, but the kind of skill and fluency that you need with coding is a little demanding. On the upside, though, my God, you don't really need to have too much access to be successful with this one. And I think it might be quite hard to detect as well. So what does this look like? I've got here this server.js, because this is JavaScript. You don't need to be a coder and understand what this is doing. But imagine instead of this code here is saying, hey, I'm going to go call example.com post with my super sensitive data. Cool. That's what internal services look like, right? Totally. Now, normally they're like this really hard to make sense of sprawling code bases. So really simplistically, you've got like 2 files you're deploying. anything sound wrong about that? Yeah. This library here, node fetch, that we're using to give us this HTTPS functionality, it's going to come with a whole load of baggage. And what's of most interest, oh, right, yes. And then this is where it comes to the significance coding effort, is if you're an attacker, you could quickly browse through the code of this internal service. You go, ooh, they're using node fetch. You know what I know about node fetch? They support agents. Cool, so if I can add in my own agent here, I get to intercept everything that goes on. So that's the effect we want to achieve. And it means we're going to want to modify, not for nothing, no accident I mentioned index.js here inside of node fetch. Because if we can change that, we can make that behavior occur. And so what are these changes going to look like? We're going to go into this we're going to go into this declaration of the effect function, and we're just going to override the agent's option and say, hey, it's our agent, actually. But then we also have to define this logging agent. Don't worry, again, if this doesn't make sense to you, but we've got a logging agent that does everything an HTTPS agent does normally, but this moment where you create a connection is the moment where we get to go, oh, we have access to the socket. Like, the moment right before everything gets encrypted. So let's change that write method to be able to intercept it. And over here, we'll keep it working. We'll add a listener for any new data that comes in. And just with those changes, that's it. We've proved that we can intercept the data. So just to give you an idea of what the diff looks like, this is a crazy long file, but like really early on, we just inserted those 2 blocks of code. Quick time check here, see how long I'm taking. Oh, this is fine. Okay. So yeah, I'm a big fan of Prove It because slides are great. And on the downside, then I'm introducing yet another thing you have to grok, which is Docker files. That's fine if you've seen it before, and if you haven't, I'm sorry. Right. So your internal service might look something like this. Oh yeah, we're a node on Buster, and we're going to be in the user source app directory. We'll put files there. We'll go install everything. And this is the important line. We'll go run node with server.js. And then, so I've prepared a Docker file of what this looks like so that it'll be compromised. First off, it's easy. Look, this is all you do, one-liner. I'm defining my own, I'm saying I'm building off this Node.js internal service, and all I'm doing is I'm going to take my pre-prepared modified index.js, that's the one you saw on the previous slide, and I'm going to overwrite the original index.js. And just doing that gets the behavior we want. And folks at the back will not see anything. It's proof that everything works. So yeah, if I go run this, Docker build, blah, 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 and it's going to do all the steps, and I'll say Docker run, and my Node.js app, all it outputs is 200, because if you totally noticed in the example code, all it's going to output is the status code of the response. But when we look at the version we modified, oh my God, look, we got to see all of the outbound stuff, and then the response. You'll notice I just trimmed this to 15 lines, so we didn't actually get everything. But mic drop, I'm done. Thank you. Actually, I got to say, it was pretty exciting to get that working. Cool, but that's great. But when can I use this? Or more importantly, when can I not use this? If you can't write to the file system, that's it. I mean, short of somehow hooking into a running node process and injecting your code and getting to yeah, that sounds like a nightmare. Basically, you need to be able to write to the file system. And then a big assumption here is that you can change those files. That doesn't do anything on its own. You need to get the node process that's running this internal service to restart. And the big assumption I have, because this is how I've seen it done everywhere as a software engineer, is you have a governing process that says, oh, if this thing dies, just restart it. Because the cost in a high availability scenario, at least, of tearing down and restarting a container, That's a lot of time you're not in operation. So very cheap to restart the process. But if that's not around, then you're going to have to start it again yourself, which may run you into trouble. Or if you're really unlucky, you kill the process and Kubernetes just says, you're done, great, I'll throw away your instance now. And then the non-trivial one is, if you're going to go in blind to do an exercise on some internal service and it's in a language you don't know, in an ecosystem you're not familiar with, that's kind of like, a challenge in and of itself. Cool, that's the end of attack path number 1. Number 2, let's go attack the binary. Let's go attack Node itself. This is probably the most intimidating one. If you think it's intimidating to go browse like some moderately large-sized internal service code base, go browse the entire code base of Node, right? There's a lot there. Not to say you can't do it, but you got to be ready for that. So back to our example, we got the very straightforward. Imagine something way more complicated is happening here. Got our server.js. And what's really noteworthy here is when fetch does its work, it's going to call to some underpinnings of Node library, I think like socket, TLS, something like that. And then under the hood of that, you kind of segue into the C code of Node, where there's various layers, and then eventually it uses OpenSSL. But so the OpenSSL that I mentioned before, commonly reused like a Windows DLL, Node doesn't do that. Actually, it compiles it in, so it's part of your Node executable. And my guess is that's really just so that people don't have a whole lot of pain installing Node. Just bring your binary, you're good. So what we're going to do then is obviously we're going to find out the responsible part of like the dependency. I see this is somewhere buried deep inside the specific Node version. They have this function called SSL write internal, which is kind of awesome because it means they've forced all of their interactions with OpenSSL to go through one function, which means, hey, we've got a point to tap into, woohoo. So my little cheat here is, let's just go add a couple of underscores in front of that. See, the function disappeared. And then let's go add our own. See, like, hey, we are the one true SSL write internal. And what's really interesting here is basically we have all of the data there. We got it. It's in the clear. Woohoo! Success, job done. And then we can make sure the app still works by going on to call the real one true function. And then we can do the same for the read flavor. If anyone knows a lot of C, they're probably looking at the side going, that's not quite right. I made it like simpler so that it fits on a slide and I don't have to worry about it scrolling off to the right. Don't worry, the real proof of concept code works and is not a lie. So the diff, I'm going to call it straightforward. In retrospect, it's like, that's it. Aha, that didn't take me hours. It's really just, that same kind of like, yep, believe me, look, see, I changed this, I added that, added these underscores, added that function. That's all I needed. The Docker file for this is, there's a lot going on here. And actually, so what is it? It's, we're getting a node buster Docker for doing our builds. We're updating everything, installing everything we need, grabbing the particular node tar that I previously downloaded and extracting it. This is the gold right here. We go, great, we have our own modified SSL libc. That's what I showed you a diff of in the previous slide. And now let's go build, make, and do all of that. And by the way, that's the bit that takes like 15 minutes. So every time you make a mistake here, you've got another 15 minutes to wait before you find out if you're right. And then, oh, right, I did this awesome Docker thing where you can say, from this as build. So this whole Docker image has all the gubbins to get it built. And then I can just say, oh, good, I'm going to take this this internal service in Node, and I'm just going to copy this one file from this build Docker over there. That makes reproduction really, really nice. And again, people at the back, you got to trust me, this just works. See, look, see? Small amount of output, a large amount of output. Still not so many preconditions for this. You need to be able to write to the file system. You've got to modify that node binary. And some of you might think, well, that's game over because that's somewhere that only users can read and execute, but only root can update, right? That's not how it goes down normally. No, yeah, I see some head shaking. Yeah, no, this is normally installed by the user that's actually running. So generally, this doesn't come with a condition for root. And then the biggest challenge is if someone's like, hey, I got this thing in, I don't know, Lua, right? Something crazy? Crazy? I'm trolling someone in the audience. You're going to be like, great, what's Lua written in? Hopefully not OCaml or something. Now I got to know that code base as well. Yeah. Although on the upside, you do that maybe once. You get it figured out for Node once. You can use it again and again. So still fairly light on the preconditions. All right, shared library attack path. This is probably the one with the most conceptual potential for confusion. It's kind of relying on a bit of how the Linux operating system works. So if you're not immediately like, oh yeah, I totally get it, don't worry. Everyone's been there. So this one needs a moderate amount of coding. It's really, really reusable. I could almost write a tool of like, here's a shared library, I'll just go nuts, right? You could use it everywhere. You might need root, depending on the context. And if you want to know more about this, it's called the LD_preload trick. So as I said before, it's a Linux shared library. Kind of think of this as a Windows DLL. It's some really highly reused code that everyone uses again without like just bundling it into their executable. So I wondered whether I should include this slide because it was incredibly useful for me to kind of understand how this is all going and then figure out what the actual SSL function is called, because I didn't know. There's this awesome, in Linux, LD_debug, and you can say all, symbols, bind, various things. And then you run the command you're interested in, and then you can look for what you're interested in. So what's noteworthy here is if I run Python to print hi on the screen, there is no reference to OpenSSL happening. Whereas if I say, hey, get me the requests library and let's go talk to a web page, then all of a sudden it's going, whoa, 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 I need this SSL readx function. Is it here? No, there, no, there, no, there. Aha, I found it. So another way of saying it is Python is not, its ELF binary hasn't said, I always use OpenSSL, or libSSL in this case. It's contextual. So as soon as you hit a code path that has to do some HTTPS, that's the moment you're going to look up the library. And the LD preload trick is the part where we get to go, no, 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 we offer that. We offer that method. Come to us. So some Python code. Basically saying what I just said. If you say request post, Python's going to use OpenSSL for that. A lot of scary C code follows. Sorry, I got a bit lazy with the presentation. It's not a slow reveal here. There's a whole bunch of includes you need, type def to say what this thing means. This is important. This is what shared libraries say, hey, I have an init function. Like, before anything happens in Node, call me. Call my init function, give me a chance to set everything up. I'm good, I'm a nice guy, honest. And that's where you can say, I'm going to dynamically load libSSL, OpenSSL, and I'm going to do a dynamic lookup for the real SSL write X function and the real SSL read function. I'll keep those. And then I'm going to actually declare the real. Totally legit. Every time you do anything, any SSL write X, you're going to see mine first. And when I get called, I'm going to call the underlying real one, and if it was successful, I'm going to print that out. And whenever you read, I'm going to call the real thing, and I'm going to print that out as well. And that, shockingly, is a really, really concise C program. And I didn't omit anything here. That's all the code. Building it is not terrible. You want like a GCC-friendly Docker image for that. There's some gubbins. I don't know. You need position-independent code. That's a thing with shared libraries. You know, you can't be relying on being loaded into memory particular addresses, and you want to produce a shared library. And so this SO prefix is convention for that. And then, yeah, again, using it is fairly straightforward. I use that same builder pattern here. So I said, hey, copy from the builder that interceptor SO. That's the thing I need. And then you've got two options. If you've got root, you can basically put the full path to this interceptor SO into this magic file name called etc ld so preload. Any blue team folks in the room? Got not very many. Well done, or bad. I'd suggest you watch for file changes on that file. Yeah. Oh, right, what does that do? I'm sorry. Every time a new executable is being started up, it's going to look at the ELF binary to see what are all the libraries it needs, and the very first library it's going to load on that list is going to be these, whatever's in that file in the order they're listed. So by being on the front of this file, you're ensuring you're the very first library that ever gets loaded, which means you can do anything.
You overwrite the entire file.
Yeah, that's in this example, the file didn't exist. Good point. I would probably want to have a slightly more complicated command to put myself at the front. Actually, or you could just append, like chances of something ahead of you on that list going, no, I'm going to intercept OpenSSL. Pretty unlikely. Generally, this file doesn't exist. Again, another hint for the blue teamers with their detection rules here. So option number two, because you're not always going to have root, is if you can modify the moment where this your service is being launched, you can use this LD preload environment variable again with the full path. There is a difference between these two, though. Any guesses? All right, everyone's too shy. Oh, guess.
The first one's at the system level?
Yes. This will affect everything. Everything that's doing HTTPS on the system will go through your library if it doesn't bundle OpenSSL with it. And this one will just be laser focused on what your internal service is doing. So you might have a preference for one or the other. But generally, you're not, because you compromise a host doesn't mean you got root necessarily. Yeah, I got lazy with doing the little highlights, but you can guess at this point. Lots of output, good thing. Oh yes, go ahead.
An interesting attack on that might be to do the LD preload, then unlike the file, but keep it open and see if the operating system keeps processing it even though it isn't there anymore.
I didn't follow it. So I keep the file open?
So as long as you have the file open, the kernel knows that it's there, right? So, if you delete it, but keep a reference open, it's not fully deleted. Okay?
Which file are we talking about? I'll repeat the question once I get it. Okay. Oh, so for evasion, rather than just append and move on, you could open the file, append, flush it, and maybe don't close it. Oh, sneaky. I hadn't been aware of that one. You put a bug in my brain. I'm going to try that now. Again, if you want to go try this for realsy, follow the link. All right, so what about the preconditions here? Again, we need write access to the file system. I don't have any examples that don't need write access to the file system. You're going to need either root privilege to modify that file in the etc folder, or you're going to need to be able to control that LD preload file, environment variable. And then you're going to need to be able to kill the process and have it restart again, or kill the process and start it yourself without setting off any alarms. And you're going to need some C coding for that. But again, someone could almost write this tool and then open source it, and then you don't have to write it. Very, very reusable. Okay, on to the last one. How are we doing for time? Oh, I'm actually a bit longer than previously. Cool. This one is the closest to a kind of, it's okay, you can leave, it's cool. I'm scaring them off. Transparent proxies, yeah. This one's the closest to bring your tool. You know, everything else has been like, do this coding. This is kind of bring your tool. So very little coding, very reusable, but because you're bringing your own tool and it kind of needs deep hooks into your operating system, chances are you're gonna be too constrained to be able to use it. And I just love it because it's the classic person in the middle, except with the surprise twist of it's got to be on the same host. And I don't think people are looking for that. Cool. So we've got the same old code as before. Again, this requests library is going to do a HTTP post. And yeah, that's going to go off and use OpenSSL that directly connects to the external service. So here's the entirety of the coding. We have this intercept pi, which is a MITM proxy script. We've got to import the one-liner there and define this response method. And basically, the person in the middle proxy will do its work, and at the end, before the client gets the response, you get the flow. When the flow includes the request and the response, you can log whatever you want, and incidentally, you can actually change whatever you want to. That's not the scope of this exercise, but good to know about. So that's it, we're done with coding. All we have to do now is get the damn thing set up. And I gotta say, doing this in a Docker file, oh God, I was cursing, because I had this all working on my own machine. I was like, oh yeah, for the talk, I'll just throw in a Docker file. And I'm up to 11:30 going, does it have to be this hard? Does it? So you've got to get, IP tables, that's got to be installed. You're going to need Python and pip. Pip is the package manager to install things. And I'm demonstrating this intercept everything. So I'm going to demo it with curl this time. This is a quirk of this method. You've got to actually add a new user. And I'll explain why later. But if I assume this Docker file assumes the identity of this user and they put the intercept file there, you've got to then install MITM proxy. This is annoying. The latest version of MITM proxy is busted because it has some sort of transitive version problem, so that's why this specific version is specified. Cool. And then you've got this kind of chicken and egg problem. You want to install the person in the middle proxy needs like a certificate or authority certificate that you can go install and trust. But how do you get it before you've run it? So this is my hack to go, hey, let's just go run that thing real fast. And that'll create a cert. Switch over to the root, grab this cert, stick it in a good location for that, and then say to the operating system, hey, okay, update the CA certificates. So blue teamers are thinking, wow, I got all sorts of things I can detect. It's like packages being installed, users being created, like processes being run, certificates being updated. Yeah, this is like open season for detection, but do you have those detections already? Maybe a purple team exercise would be a good idea. Cool. And then this is the more of the pain that I had. I want to do some privileged things now, like modify IP tables, but I can't do that inside a Docker file, because you can't just say -- privileged when you do a Docker build, because that's not how that works. You have to install a build extension and just, oh my God, pain. So I just moved it to this entry point shell, and that's going to do this magic. Oh my God, this is awesome. All right, I'm going to read this. So IP tables, it's like a wrapper in front of the netfilter kernel. You can say, okay, I'm going to do some natting. It's for the TCP protocol, where the originator of this connection is not the MITM proxy user. That's an important detail. That's why we created this user over here. Where it's not this MITM proxy user, and you want to connect to 443, send it somewhere else. And what I love about this is nothing notices that this is happening. Like from the client perspective, like anything talking to the outside world, when they get their socket back after they've connected, it's got all the metadata as though this thing didn't exist. Love it, love it. Don't worry if like pre-routing, redirect, whatever, is like, what the hell is this? Because that's okay. And then we actually need to be this MITM proxy user. This is just logging in and then saying, hey, the MITM dump, which is like the headless version of MITM proxy, let's go run that in transparent mode, and here's my script to go run. And that is all you need, except you actually also need to go exercise it. Did it work? If I call example.com and I post super sensitive data, and I suppress my output, what do I get? Clearly, complete success. Look, output. All right. So, oh my God, a boatload of prerequisites. you need write access to the file system. Who doesn't? You need Python pip, and to install MITM proxy. You need IP tables to add pre-routing rules. You need root privilege. You've got to create a user. You need to install a CA certificate. You need the netfilter kernel to be around. You need cap net admin. So in Docker parlance, you basically need a -- privileged to your run. And you need a small amount of Python scripting skills, although ChatGPT is probably going to be fine. Hey, who doesn't? No shame, no shame. Cool. Q&A break. I'm going to take a complete tangent onto the blue side, and feedback I got was, here's a good moment to take a pause and see if there are any questions. Go for it.
Hi. Well, it doesn't necessarily have to be used by an attacker. I use MITM proxy for security reviews when I have a piece of software that is basically a black box and I want to understand what's doing. Like who is talking to, what is sending around. So
Yeah. So, member for the audience said, MITM proxy is amazing. You should use it for everything, especially pen testing and security reviews. And I concur. It is just great. If anyone uses Burp Suite, then you're kind of stuck in like clicking and, yeah, no, just use MITM proxy. It's amazing. If you're comfortable writing Python, then yes, definitely use MITM proxy. I think I saw a hand. Yeah, Micah.
I was curious, for the transparent proxy, a lot of the restrictions require root level. Have you considered hijacking the environment variable for HTTPS proxy, and how many steps might that reduce?
Okay, the question is, MITM proxy is a whole load of preconditions. How about you, have you considered, definitely, have you considered modifying environment variables so things just use proxies? No, I hadn't thought of that at all. That would be awesome.
I've actually done this myself. If you use the HTTPS proxy environment variable, you can plug that, you can make it do whatever you want, and it will send all of the data to it, even if it's going through a plain text proxy. You can define a plain text proxy. You can even define bash code inside of that environment variable, and it's locked to the user for that session, but you can put that on the user profile if you have control.
Mike is saying it works totally. Although Dockerfile or it didn't happen, I'm just going to say, yeah. No, I'd love to see that. I'm personally super curious. So if you can shoot me that, I will use that if that works. Great. But Dockerfile or it didn't happen. So. All right, if you're feeling like I might want to raise my hand, but should I? Yes. All right, I'm going to move on. And if you're like, question. Why are we using Docker files? It's because I have a Docker file fetish. No. It's because, actually, if I have a fetish, it's for like making the work that I do be reproducible by other people, so it's not just complete. I want to be able to see someone else's work and go, how do I know this works? Show me. And they go, oh, here's a Docker file that shows me it works. Great, now I'll pay attention. And so that's why. No, although if you did get their CI/CD access, maybe you want to add a few commands to their Docker command, the Docker file. But no, it's just purely for reproducibility. It's purely for y'all to go, okay, this is working, I believe it. Yeah, no, where the Docker file is saying, hey, copy from here to here, that's, you're going to be in a shell somewhere going, copy this file, or curl and output it to this location. All right, and time, moving on a little bit. All right, cool. Mid-journey love, anybody? I said proudly defending against cybersecurity attacks. Blew my little pony. All right, so preventions. This is just one slide. Ready? Okay. So you've got a lot of options. Like a read-only file system, done. Anyone thought at work this was a great idea and a team should just go do that? Cool, how did that go? It went just great. I haven't got that to happen yet. If you got a brand new thing spinning up and you go to a security review and you're like, let's start with a read-only file system. Yeah, that might work. Something that already exists, forget about it. This one is probably the easiest, kind of almost a read-only file system. Like, what if the node binary is just read and executable and it's owned by a user you don't have access to and you don't have root on the system, hopefully? That's pretty good. It's pretty good. So I assert you can get a long way with this. And then, other practices, like if you're going to install your own node, have that not be owned by the user that's running the service. Generally not having a root user, how many times do you see an engineer shipping something, they have a Docker file and it says, there's a line in it that says user and then some not root name. I actually haven't seen it. Like everybody just runs their services as root. Like, oh please, you're making it too easy. Make it harder. Just say user not root. Success. But actually this blocks maybe just one of these techniques. But it makes it harder, right? You want to, defense in depth, right? I hear that's a good thing. And then, please just don't run privileged Docker containers. Anyone seen a privileged Docker container at work running actually in the wild? Did you get that? Did you manage to get that privilege taken away? You did. Well done. And again, something you can do from the get-go, really hard to do later, is, hey, let's just use Alpine. Let's use some really slim OS and add the things you need. Let's not leave GCC lying around, right? Or just let's go distroless. Like, what about a single Golang binary and that's it, right? Again, you can't come to a project that exists already. Oh, go ahead.
I don't know if this is like an appropriate time to add this. I work on read-only file system embedded Linux stuff. If I have root in a normal system,
you can still remount, right?
Remount it, and if I can't remount it, I can bind that over. Historically, I have worked on systems where we took that code out of the system. We were compiling everything from scratch, and we said, you can't do that. We took that code out.
Great. I want to repeat the question. And it's like, so what if you have this read-only file system? Because what if I unmount it and remount it? Well, crap. Depending on the environment, I think Kubernetes makes this really easy to do. There's, was it Linux security module, something, Stardust, go Google it, that will do this for you. Actually, I've experienced this myself. I've, off hours, bug mounting. Yeah, I've got root. Oh shit, why can't I see proc? Why can't I mount my own things? Ah, damn it, they've locked it down. Yeah, I mean, actually a tip for that in general, without going too long, hopefully, is you go pretend you're a hacker who's broken into one of your containers. Just go run one of those enum for all the things scripts that you can find, and follow anything that's in red or highlighted in what was it, brown with white letters or something. It's basically saying this is the thing to look at. Go check that out. See if you're missing something. And in case you all are thinking, why didn't you stop anyone from breaking into this host in the first place, or stop them getting the data out, is yes, you're already working on that, but not in this talk. Okay, last slide of any material content. And 15 minutes to go, we got this. Actually, 5 minutes to go, we don't got this. So detections. And the reason this has a purple pony, because you don't tend to get the detections. Detections is a blue team thing, right? Right. But you tend to get to that level of maturity once you're starting to do this purple teaming. Once you got the adversarial mindset working with the defensive mindset, that's when you're all like, shit, we need detections, don't we? Right, okay. So you got a lot of options, and the downside is this tuning required. And maybe the other downside is, do we need a team now to go listen to this stuff? Okay. This is not my forte. So a lot of this is keywords I have from friends. File integrity monitoring is kind of like, am I going to notice a file changed? Binary file attestation is going to get half of these. Is like, hey, this node process, what's the hash I'm expecting to hey, it's different. Stop it. Or maybe something like Falco, where you can say, yeah, there's some really important commands no one should be running on this host. And why can't you just remove them? But anyway, there's some really important commands no one should be running, and let's go alert on those. And that's going to detect everything, asterisk. And then process monitoring, and then maybe, I guess I should add to this list, intrusion detection for all the things like creating users and installing certificates and various things like that. I had in mind some cool tools that people use for this, like Falco. No, falling out of my brain. Come talk to me if you need them. All right, so what did we cover? Well, we covered things with awesome names. Interpreted code attack path. So this is lots of coding, but is the most flexible. You've got the language binary attack path, which is, frankly, you want to tap the shoulder of your software engineering friend to do this, because it's not light amounts of work. A shared library attack path, let's leverage that awesomeness of preluding libraries in Linux. There's a moderate amount of coding, but once you have it, you can use it again and again. You might need root, depending on your circumstance. Transparent proxy is awesome, and you should use it. Try it out, just because how fun it is. Very little coding, very usable. Oh my God, why didn't I just do what Micah said and just set the proxy as an environment variable? And then for preventions and detections, you've got lots of options. My God, if you can just lock down writes to files, you can walk away, at least for the examples that I've shown. And all of your detections, you're going to need some tuning. And that's all I wrote. Q&A slide. Midterm proxy, how does it deal with HTTPS? I think that's not a problem at all. It's not pinning to a particular certificate. It's just saying this site can only be visited when it's...
Okay, I think maybe it's just because it's Google or something.
I can...
Some of the browsers scratch.
Oh!
Yeah, like Firefox.
I use Firefox, so, I don't know.
So yeah.
Good point.
Yeah. Anyway, just curious.
I'm not sure if I repeated the question, but what about HSTS, which is that header, which is saying, hey, only HTTPS, please, for this site? I have not run into any problems at all with midterm proxy and doing that.
I'll have to play with it. Lesser proxies will generate failed certificate errors. And so I've been kind of exploring what works, what doesn't, and what's the difference between my enterprise web filter that's transparent and I can go to SourceForge,
Yeah.
but then I use my little homeworld Python one and I can't, and the browser throws a fit, and so.
So if I want to summarize, tell me if I got this wrong, because not everyone can hear you, right? How well does midterm proxy handle all the things that I've seen go wrong? I've not had any problems at all, is my short answer. It's got a lot of active development. It's not like some stagnant thing. Yeah. If you wanted to contact me, there's an email address, if you can parse out what these words mean. And if you've got an idea like, hey, why don't you just use the environment variables for proxying? Yeah, I want to know about that. And if you're like, well, that's cool, what else is there? I've created a throwaway alias for this talk. come talk to me in person if you want some other related material. All righty. Thanks, folks.